Welcome. This is lecture number 28, I think. We are going for question number 2. See correctly how I wrote. First you start from here. Question 2. Question 1 was a critical question. I solved 8 times for line of action of resultant location. And everything is so thoroughly explained. Therefore, now onwards, I will solve it briefly. You should have some contribution required from you also. If you want to learn, and if you cannot work hard, then you won't learn. So now onwards, see, this will continue for all, everywhere. Once something is very thoroughly explained, unless there is some changes are there. If changes are there, I will tell. If it is same routine, once again, then what I will do is, I will just give brief solution and some important information if it is there. And remember, in the class, I will solve limited number of questions. Whereas in the notes, if I solve 4 or 5 questions in the class, there will be more than 10 questions there in the notes. Therefore, for those who are sufficient this class, you manage from this one, or you have to take the notes and work out every question to get complete knowledge. Okay, now find the resultant for the given coplanar force system completely. Now I won't tell. Those who want write completely means how many times I am telling magnitude, direction and line of action. Over. Start. Force system given here. These 2 couples I kept pending because I want to adjust it. Why? I will tell you why I want to adjust it. See, last time when you consider point somewhere here at x from A, we got negative sign. This time I want positive sign. For that purpose, if the given forces gives negative sign, I will adjust by the couples. I can do adjustment. For you, question given. Okay, this I will give you little later. Both are given in Newton meter. Okay, this is a question. Okay, start. First step. Don't see here now. Solution. Resolution of forces. X, X, Y, Y, you write. Consider 90 Newton force at D. See here. It is going this way. Angle is not given. 4 vertical, 3 horizontal given. Okay. Now, consider the point D. See, 90 is this way. This is 4, this is 3. Let the angle made by 90 with horizontal be theta 1. If that is theta 1, this is also theta 1. Y means no answer for engineering. Those who are studying structural engineering, if this is theta 1, why this also is theta 1? If that is not clear, better not study any structural subject. Okay. Tan theta 1 equal to 4 divided by 3. I calculate theta 1, 53.130 degrees. Therefore, now see resolve horizontally right component, vertically up. This is all I told for you. Those with difficulty, take a pencil mark here, right and up that. Now it is too late. Now if you cannot see, the force is going this way, one component like this, one this way. Our angle is with horizontal, xx. So x component cos, y component sin. I wrote 90 cos theta 1. You do one thing. You write here. You enter the theta 1 here. How much? 53.13. Enter here. Then write 90 cos 53.13. You write that way. There is no place to enter here. So I am putting theta 1. Now you know the value of theta 1. Get the 2 components. See, later at D, see here, I entered a right. This sketch will come last, not now, when everything is over. Don't come here now. So at D, right of 54 Newton and up of 72 Newton. Okay. Now 90 Newton force is over. Consider 200 Newton force here at A. Okay. Again same, it is given this way. See, let the angle be theta 2. Now, they told 3 horizontal to 2 vertical. So, if this is theta 2, this is also theta 2. Why? Angle made be line with the xx, here also with the xx. Or, see, that much you can make out. If this is theta 2 with, see, this force, horizontal theta 2 means horizontal theta 2. Tan theta 2 equal 2 divided by 3. Theta 2 will come 33.690 degrees. One component like this, 200 cos theta 2. One component like this, 200 sin theta 2. I got the answer. See, I entered here. Write 166.410, 41 sufficient because 0 is not required. 110.94, this force over. Now consider 80 Newton and 100 Newton. See, 80 Newton, you know 2 points. It is, see, from E, there is one point is E, other point is F. See, class, I am telling. When you resolve 80 Newton, you can resolve wherever you want, either at E or at F. But be careful, after resolution, after you can resolve anywhere you want and consider the components either at E or at F. But remember, either you consider both components here or both components here. Do not consider one component here and one component here. Gone case. See, this way. So what you can do? Anywhere you can resolve. Okay, we will resolve this 80 Newton at E. Written here. Let us resolve and consider component at E. Why E means? No. If you want, you resolve at F. Somebody will tell, sir, if you resolve at F, and if you resolve and consider the component at F, later when you take moment, there will be change. Yes, correct. Term, see, here this component into this distance will come. If you resolve here, the same vertical into this distance will come. So some will tell, sir, moment answer will change. No, it will adjust itself. What change came for vertical, same change will come for horizontal component. Then when you consider both of them, 100% same answer will come, irrespective of you resolve at E or at F. When you take moment, there is no effect, my guarantee. Okay, right. Anyway, see, you cannot keep on thinking, shall I resolve E or F? Decide fast. Okay, E, done. E, I wrote here, E. See here, E point. 80 Newton this way. We want this angle for resolution. Not given. So what you do? See, E, you consider a triangle, right angle triangle. See, here, this triangle, that much you can make out. Okay, E, F, see, this point you call F dash if you want. See, F dash is here, somewhere here, F dash. Okay, now, we want this distance and this distance. This distance is crystal clear, 30 centimeter, crystal clear given. This distance is, see, we want, which one? This distance is, see here, 40 minus 6 minus 18. See here, this full is 40, this is 6 centimeter, this is 18. See, we want this distance. So, 40 minus 6 minus 18 will come 16. Class means I explained you how you got 16, right here. 40 minus, how much it is? 6 minus 18. That's how you got 16. Now, if this is theta 3, this also theta 3, tan theta 3 equal to 30 divided by 16, you got the value of theta 3. Now, one component this way, 80 cos theta 3, one component this way, 80 sin theta 3. I got both the components. See, at E, I entered both the components. One this way, one this way. Lastly, consider 100 Newton force. 100 Newton force. See, you know 2 points. One of them is G, other is E. You can resolve anywhere you want. You can resolve at E only if you want. But E means, see, I already got 2 forces now. Another 2 forces will come there. One here, one here. So, little mix-up will come. Do one thing. You resolve at the point where there is space to write. If you resolve at E, see, already 2 components here. You get another 2 components there. I have to rub and write it. So, what you will do? Easy. We will resolve at G. Class. We will resolve and consider component at G. Class. Okay, now, this 100 Newton force through G. See here? G. This way it goes. We want this distance and this distance. This distance is 18 centimeter. Why? Directly given. Height is, this is 30, this is 7, this will be 23 centimeter. See how I got 23? 30 minus 7. Now tan theta 4 equal to 23 by 18. You get 51.935 x component, 100 cos theta 4, y component, 100 sin theta 4. Get the component. Now, see, I resolved at G. See, one vertical component up 78.751, horizontal component left of 61.631 Newton. Okay. Now, what I will do is, I will tell you the values of couple. For that, I should do some calculation. What I will do now is, I will now somewhere in the corner, I will do all the calculation and make a note to save the time. But I will show the calculation here, but I want to waste time during the class calculating. Okay. I solved the question completely. Now, in the original question, I am not given the couple. This couple is 60 Newton meter. This couple is 40 Newton meter. Given in the question. Okay. Now, I told everything is neatly entered. Now, those two couples should be entered. See. But before you enter, see, this all I explained. I think I can rub this one. These are all not required now. See. These are all not required. I can rub all this one. This can be fully rubbed out. Because I explained everything. Yes. Everything explained. This fully can be rubbed. Now, one important note you have to make. I think this is wet cloth actually. I want dry cloth. Again, same problem, missing. I see here. Okay, got it. Luckily got it. Because if it is wet, I can't write immediately. Okay, now. See, after resolution of all the forces, I made a neat entry here. Now I want this distance. Write neatly distance. How much it is? This is 30 centimeter. Little wet, that's why not coming. Okay. This distance is, okay, we want one more marking there. Okay. I'll do one thing now. Okay, this distance is, this is 72 Newton. I'll check the camera once again. 72 Newton. Okay, this is 40 centimeter. I write once again, no problem, 40 centimeter. Now, one very important concept. In the question, forces are given in newtons. Okay, we consider Newton. Distance given in centimeter. So, therefore, make a note here. Note, we will solve in terms of Newton and centimeter. See, last time millimeter, this time centimeter. But before going further, make a note. Two couples are given. See, consider the couple. Consider couple of 60 Newton meter. Right here. So, Newton okay. But when you take moment of the forces, see, force in Newton, distance in centimeter, moment will come in Newton centimeter. This is Newton meter. So, right here, this should be converted to Newton centimeter equal to 60 into Newton remains Newton, meter I want centimeter. All are knowing 1 meter equal to 100 centimeter. That much you should know, or equal to 6000 Newton centimeter. Similarly, other couple 40 Newton meter equal to 4000 Newton centimeter. Therefore, see, I entered here 4000 Newton centimeter anti-clockwise couple and a clockwise couple of 6000 Newton centimeter. This is, now it's a wet actually, no problem. Now it is dry. 72 Newton. See now, this distance you may require for moment calculation. It is 7 centimeter. A, B, C, D. Now, there is one point here. For taking moment, you require this distance. See, in the question they told this is 18 centimeter, right here. 18 centimeter. Okay, everything is ready. Now, the question is all for you. I need not continue. Still, I already calculated everything. Everything is ready with me answer. So now I will calculate one by one. Okay. Rub and start now only. Why unnecessary? Pause. Now remember now, I won't too much time waste the time because everything is known to you. You should correctly solve systematically. Start. Because I already got everything ready there, I can use it. That is the advantage of what? Recording of the class. Live means no problem. Some students will give the answer. See. Now I won't waste time unnecessarily telling same thing again. I want red color for that one. I almost forgot where is red color. Same. When I want a particular color, I won't get it. It is not here today. It is happening class after class. Search for a particular color, you won't get it. Here. Yes, here. Okay. Okay. Now start. Now remember, systematically solve last time your calculation. Right. Algebraic sum of the components of all the forces in x direction. That is called sigma fx. I will take right side positive. Start. Plus 54 minus 37.646. Next question, I will not do this also. Remember, second question, so I am solving little more. Then minus 61.631 plus 166.41. Just I'll do one thing. The top, I won't check the camera once. Is it going out of camera? I think it is visible. Oh, crystal clear visible, no problem. Okay. When you calculate, it will come. I already calculated it. It will come plus 121.131 Newton. Therefore, your sigma fx without sign is 121.131 Newton to right side. See, last time negative came, we put left side. This time positive came, right side. Okay. Then, algebraic sum of the component of all the forces in y direction, sigma fy equal to, this pen is not writing, okay, sigma fy equal to, we will take upward positive, start here, plus 72 minus 70.589 plus 78.751. I will tell one more thing later. Minus 110.94. Usually I am careful while calculating. But if by chance in engineering mechanics and strength of materials for some questions, if there is a calculation mistake is there, you correct it. Or if the answer is wrong, you continue the wrong value only, so that further steps you can check. But not for structural analysis, there I know the answer. I would check and check. No, I did not check it. The moment I get the answer, I can make out correct or wrong. This will come minus 30.778 Newton. Therefore, your sigma fy equal to 30.778 Newton to negative came, so downwards, over. Okay, these are right. Now, next. Now, see, any point you mark here. I'll mark here. Any point mark here. Sigma fx came right side, right here. Sigma fx equal to 121.131 Newton. Sigma fy you got down equal to 30.778 Newton. Now, what all I told last time, go through it. If it is a concurrent force system, you know this point. Now we don't know. So call this point as x. So right here, let x be any point which lies in line of action of resultant force. Okay, now next statement. You should write R be the magnitude. You should write, if you are serious what all I am telling you, write R be the magnitude of the resultant force. Let alpha x be the angle resultant force makes with the nearest horizontal x. So your R equal to square root of sigma fx square plus sigma fy square equal to root of 120. Here you should not see there, no sign now. 121.131 square plus 30.778 square root will give you, there is answer, 124.980 Newton is the resultant. Then also tan alpha x, I told 1000 times, is sigma fy by sigma fx. Now I won't waste time. Sigma fy is 30.778 divided by 121.131. Sometimes student will say, sir, last time you told alpha equal to tan inverse. This time you told tan alpha. If that much is not clear, don't continue the class. Or write alpha equal to tan inverse. Both are same meaning. Therefore, you get the value of alpha x equal to 14.257 degrees. So now, right, we know the magnitude, we know the direction, but line of action is not known. So now, last step to locate line of action. Last time, 8 times I told, these all, now you can solve only once. Okay, now, to locate line of action of resultant force. Remember, already I told you, let x be any point which lies in the line of action of resultant. So that is to locate that point x. To locate that point, unknown point x. Okay, now let us locate your see question, nothing given. Let us locate resultant R on AB line with respect to A. Okay, on AB line with respect to A. Okay, next, let line of action of resultant R cut AB line at x, comma, at small x from A, as shown. This all last time 8 times I told, remember, right here. Show a sketch. I am rubbing something because I don't want to, I want space here. Yes, okay, see here. I am locating with respect to A on AB line. This length is 40, somewhere here, I don't know where is it, somewhere mark here, point x. Then through the point x, how resultant goes this way. See, your resultant is like this. It's a resultant. So here you enter those components because easy for moment. Enter sigma fy here, how much? 30.778 Newton. Enter sigma fx here equal to 121.131 Newton. Okay, now from A, this is the point x, we don't know. From here to here is our x. Okay, this all 8 times I told last time, remember, not once. Okay, now to get x. Now I won't write. Apply Varigno's theorem. Some will tell, who is this person? Not telling anything, simply dictating. I will tell them, see last time master question. Don't come to this class and comment. I struggled so much in the last question. very famous theorem. Consider moment about, now moment about A only you have to consider. Why? Because you are taking x from A, right? Algebraic sum of moments of the given force system about A equal to moment of resultant force about A. About A. We will take clockwise positive. Left hand side is algebraic sum of moment about the point A. See here. Start here. 110.94 into 0. 166.41 into 0. I won't write. 72 also into 0. You write if you want. 54 into 30. Moment will be in what unit? Moment will be in Newton centimeter. Moment. Okay. 54 into 30, even 37.646 also into 30. This is clockwise, that is anti-clockwise. Okay. Plus 54 into 30 minus 37.646 also into 30. Then 70.589 clockwise plus 70.589 into, see, this is 40, this is 18 into this distance is 40 minus 18, you write 22. Write later how 22 came, 40 minus 18, then minus 78.751 into 40, minus 78.751 into 40. I will remove this one now, this space I don't want. Okay, okay, then minus 61.631, the block is there. Okay, okay, now okay, 631 into moment about this point into 7, next plus 6000, no into minus 4000, no into, it's already moment, equal to, see here, moment of resultant here, sigma fx into 0, you can write if you want, sigma fx into 0 and sigma fy, it is clockwise, sigma fy into x, this is into x, sigma fy is how much? 30.778. Therefore, you get the value of x. See, if you calculate the left hand side, it will come, where I wrote it? I wrote it there. 4 plus 462.121. I calculated. So your x will come plus 15.015 centimeter. Now, one note, you are right. We considered the point x to right of A. And answer came plus, means correct. Last time negative came, so we went left side. This time, see, we considered the point x to right of A. Answer came plus. It is correct. And A to B is 40 centimeter. It came less than 40. So, it will be really after A, before B. See, by chance, if you get more than 40, then what will happen? Suppose you got 48, what to do? From A, you have to go right side by 48. It will cut somewhere here. This all will come in the further question, homework questions. Okay. Therefore, resultant cuts here. Therefore, lastly, present the answer. Neatly write the answer for the resultant. Right. Neat presentation. Therefore, conclusion. Therefore, resultant, okay, red color is required, okay, red color is not required, therefore, resultant force for given coplanar force system is as shown below. As shown below, how below? Okay, put a neat sketch. 30 and 40. Okay. A, B, how much? 15, 40, somewhere here. See, somewhere here. Angle is very small, this way. This is the resultant magnitude equal to, where is the answer? 124.98 Newton, 8 Newton, and angle it makes with horizontal is 14.257 degrees, and that point cuts the AB line to right side from A by a distance of 15.015 centimeter. Magnitude, direction, and line of action. Over. Now, those who are interested, you find where resultant cuts this line. Take the point here, along AD line if you want. You have to get this distance. If you take it as Y, you have to get it 3.815 centimeter. I calculated. You will get the answer. That means this point you will get. By chance, if you took the resultant at x from B to left side, your answer will be 40 minus 15.015. See, that is around how much? 24.085. See, suppose by chance you took the resultant here, just for fun, let the resultant cut the line at a point x, at x to the left of B. Yes, it is left only. Your x will come 24.085 centimeter. Why? If this is 15.015, that will be 24 point something. Or if you cut this line, you will get this distance. If you cut this line, you will get, see, this point. Anyway, that all we have covered last time. Now, thoroughly practice this question. Next class, I will give some 3-4 homework, easy questions with a brief solution. Then I will change over to other part. I will tell about the replacement and moment and couple and parallel forces. Whereas in the notes, plenty of questions I will solve for this one. Because there, it is my responsibility. When people take notes from me, I should give maximum information. But those who are serious, you can study from here, understand everything. Okay, thank you. We'll meet in the next class.